In this video, I'm going to talk about how to identify overfitting machine learning models. What is overfitting? As you know, when we build our model, we are going to use training dataset to train our model. And after we build the model, we are going to use other dataset to test our model. Overfitting is the case where model performance on the training dataset is improved at the cost of worse performance on data not seen during training, such as a holdout test dataset or new data. If the performance of the model on the training dataset is significantly better than the performance on the test dataset, then the model may have overfit the training dataset. In this video, I'm going to demo two examples about overfitting. The first one, I'm going to use decision tree. I have another video explain what decision tree is and how to build decision tree in Python in my YouTube channel. If you haven't watched that video, you are welcome to watch that video first. Now, I will explain how a decision tree works briefly. By using a decision tree, basically we want to classify our data points based on a sequence of conditions. When we have a data point, we are going to use first condition to classify this data point. If this data point satisfies the first condition, it will go to left. Otherwise, it goes to right. If it satisfies the condition, we are going to use the second condition. And same logic, if it satisfies the second condition, it will go to left, otherwise go to right. Eventually, it will reach the final conclusion. As you can see, if we have more layers of this decision tree, or we have a very deep decision tree, we can have more small groups about our classification. How can we do overfitting test for decision tree? We will enumerate each tree depth, fit a tree with a given depth on the training dataset, then evaluate the tree on both the train and test sets. We can imagine if we increase the depth of the tree, the training dataset will fit the model better, but not necessarily for the test sets. The expectation is that as the depth of the tree increases, performance on train and test will improve to a point, and as the tree gets too deep, it will begin to overfit the training dataset at the expense of worse performance on the holdout test set. Now, let's go to Python, see how can we implement that overfitting test. First, I'm going to generate 10,000 sample data with 20 features, but only 5 features are informative. Then I'm going to split the data into training set 70% and the test set 30%. And then after the training, I'm going to evaluate how it works for the training set and for the test set. Let's run the program. In this test, I'm going through from 1 to 21 at the depth of this decision tree. So you can see at the beginning the accuracy increased for both training set and the test set. But after a certain point, although the training set accuracy increases continuously, but the accuracy for the test set stopped around here, maybe about 8. And then after that, the accuracy even dropped. So you can see the overfitting problem happened here. If our decision tree has too many depths, it will overfit the training set and cause a problem for the test set. The second example I'm going to use in this video is using KNN algorithm. In my YouTube channel, I have another video explaining what KNN algorithm is and how to implement that in Python. If you haven't watched that video, you are welcome to watch that video first. Now, I will explain the intuition of KNN algorithm briefly here. The KNN algorithm is trying to classify an unknown data point based on what are the closest data points. For example, we have a green circle here, and we don't know what kind of data it is. And then, if we pick up one closest data point, and this data point is a square, and we are going to say because this data point is close to this square, it must be a square too. But if we have a larger circle, we pick up 3 data points. Because there are 2 triangles here, only 1 square in this big circle, then our conclusion will be this data point must be a triangle because there are more triangles closest to this data point than the square. That's the basic logic of KNN algorithm. Then, how can we do overfitting test for KNN algorithm? We can use different configuration values to build our model. For example, we can use number of neighbors from 1 to 50. And we are looking for a pattern where performance on the test set improves and then start to get worse, and the performance on the training set continues to improve. Now, let's go to Python, see how it should work. Similar to my previous example, I'm going to take 10,000 data points with 20 features, but only 5 features are informative. And we'll split the data 70% to training set and 30% to test set. And then for the number of neighbors, we are going to take from 1 to 51 and then run the program and to test the training set and the test set. Now let's run the program. You can see the number of neighbors is 1, 2, 3. It keeps running. I'll cut the video here to save some time. Now the process finished. Let's take a look. This is the training set and this is test set. And as you can see, the test set at the beginning it increased accuracy, but about 5 or 7 it reached the peak, and afterwards it is flat or even decreased. So we can see overfitting happened from this point. So if you want to build a model, maybe you take number of neighbors 5 or 7, not more than that. This is how you identify overfitting machine learning models. Please provide your comments and subscribe to my channel. Thank you very much for watching.